Coral reefs reflect the fragile beauty that exists within all ecosystems. These are places that are to be valued beyond measure for all generations. Yet they are now one of the most threatened ecosystems on Earth, with 1/3 of the world's coral species listed as vulnerable or endangered. The rate at which carbon dioxide is increasing in our atmosphere will create an entire altered ecosystem on the reef. It's not just corals that will bleach, but iconic species like the manta ray that are threatened. The University of Queensland's Project Manta studies manta rays as bioindicators, animals whose very survival indicates the health of the coral reef.
The manta ray, big animal, up to 9 meters across. You could do aerial surveys and pick them up very easily. So that's why I feel that manta rays are a particularly good bioindicator, because we can see them from afar.
The manta ray is the world's largest ray, but it's also listed as vulnerable to extinction on the IUCN Red List for threatened species.
Manta rays are one of the largest bodied planktivorous animals in the Great Barrier Reef area. It feeds solely on plankton, which is the microscopic component of the water column. One of those things that's really being earmarked of being really affected by potential climate change. It's a little bit more difficult to see a plankton, particularly from the air or any place like that, whereas a manta ray, big animal, and if we start to see changes in their population, in their dynamics as to where they are, I think it can really give us some sort of idea or some sort of handle on what's happening within the GBR.
Project Manta identifies manta rays using simple underwater photography. Manta rays can be identified by the patterns on their underbelly.
They have a distinct set of spots and dots underneath their belly, and those spots and dots patterns are just like a fingerprint. It's unique to every individual. So we can do all sorts of things with a database that has very simple information, like estimate population sizes and also really broad-scale distribution patterns.
Researchers from as far away as Japan and Fiji can help the scientists at the University of Queensland begin to build up ideas of migration patterns and notice changes in food availability. Project Manta is also another way the general public can get involved in science. Divers who spot a manta ray are asked to take a photograph of its underbelly, note the location and date, and send the information to the project. Over 400 unique mantas have already been identified. This compiled data is crucial to the analysis of the impact and intensity of climate change. The effects of the extreme levels of excess carbon dioxide that we put into the atmosphere can be tracked by its direct impact on the ocean environment.
Changes in sea surface temperatures can change the dynamics of the plankton, of where it's available and how often they reproduce and how much is there.
CO2, when it goes into the atmosphere, also goes into the ocean. And when it goes into the ocean, it reacts with water and creates a dilute acid.
Because a lot of these organisms, these microscopic organisms, rely upon making a calcareous test of some sort or an outer coating. And if you make the ocean more acid, it means that these animals literally dissolve and they won't be able to survive. And so what you're doing then is messing with these manta rays' food source. And so we're following the manta rays, following the plankton.
If you'd like to contribute to the research of Project Manta, please visit their website for more information.